One of the biggest mysteries in astronomy is the question, where did all the antimatter go? Shortly after the Big Bang, there were almost equal amounts of matter and antimatter. Now I say almost because there was a tiny bit more matter, really. And after the matter and antimatter crashed into each other and annihilated, we were left with all the matter we see in the universe. You and everything you know is just a mathematical remainder left over from the great division of the universe's first day. Now, we did a whole episode on this mystery, so I won't go into it too deeply. But is it possible that the antimatter didn't actually go anywhere? That it's all still there in the universe, floating in galaxies of antimatter, made up of antimatter stars, surrounded by antimatter planets, filled with antimatter aliens? Aliens who are friendly and wonderful in every way, except that if we hugged, we'd annihilate and detonate with the energy of gigatons of TNT. Sort of tragic, really. If those antimatter galaxies are out there, could we detect them and communicate with those aliens? First, a quick recap on antimatter. Antimatter is just like matter in almost every way. Atoms have the same atomic mass and the same exact properties. It's just that all the charges are reversed. Anti-electrons have a positive charge. Anti-hydrogen is made up of an antiproton and a positron instead of a proton and an electron. It turns out this reversal of charge causes regular matter and antimatter to annihilate when they make contact, converting all their mass into pure energy when they come together. Now, we can make antimatter in the laboratory with particle accelerators, and there are natural sources of the stuff. For example, when a neutron star or black hole consumes a star, it can spew out particles of antimatter. In fact, astronomers have detected vast clouds of antimatter in our own Milky Way, generated largely by black holes and neutron stars grinding up their binary companions. But our galaxy is mostly made up of regular matter. This antimatter is detectable because it's constantly crashing into the gas, dust, planets, and stars that make up the Milky Way. Stuff can't get very far without hitting anything and detonating. Now, back to the original question. Could you have an entire galaxy made up of antimatter? In theory, yes. It would behave just like a regular galaxy as long as there wasn't any matter to interact with. And that's the problem. If these galaxies were out there, we'd see them interacting with the regular matter surrounding them. They would be blasting out radiation from all the annihilations, from all the regular matter, gas, dust, stars, planets, wandering into this antimatter minefield. Astronomers don't see this as far as they look, just the regular, quiet, calm matter out to the edge of the observable universe. Now, that doesn't make it completely impossible, though. There could be galaxies of antimatter as long as they're completely cut off from regular matter. But even these would be detectable by the supernova explosions within them. A normal matter supernova generates fast-moving neutrinos, while an antimatter supernova would generate a different collection of particles, and this would be a dead giveaway. So, there's one open question about antimatter that might make this a deeper mystery. Scientists think that antimatter, like regular matter, has regular gravity. Matter and antimatter galaxies would be attracted to each other, encouraging that annihilation. But scientists don't actually know this definitively yet. It's possible that antimatter has anti-gravity. An atom of antihydrogen might actually fall upwards, accelerating away from the center of the Earth. Physicists at CERN have been generating antimatter particles and trying to detect if they're falling downward or up. So if that was the case, then antimatter galaxies might be able to repel particles of regular matter, preventing the annihilation and the detection. Now, if you're hoping there are antimatter lurking out there, hoarding all that precious future energy, I'm sorry to say, but astronomers have looked and they haven't found it. Just like the socks in your dryer, we may never discover where it all went. What other mysteries in astronomy and physics fascinate you? Let me know your suggestions for future episodes. In our next episode, we look for virtual particles with Dr. Paul Matt Sutter. Oh, and make sure you stick around for the blooper. If you enjoyed this video and want to support the creation of space and astronomy news, videos, podcasts, and more, you should join our Patreon community. There are 525 amazing patrons working with us now, funding the work that we do on Universe Today. They get to see our videos ahead of time, hang out with me and the team, and see unreleased material. And we'll remove all the ads on Universe Today. We'd like to thank Jeff Crockett, Bruce Heyman, and Lars Komienzispat. I hope I did that all right, Lars. And the rest of the members who support us in making great space and astronomy content. Want to get in the action? Go to patreon.com/universetoday. And I say almost because there was a tiny bit more matter. Really, and alter the matter. Oh, okay, hold on. What? After the matter. Sorry, really, and after the matter. Never mind. I'll be all right. Let's start again. All right. Okay, and I started with my little widget in the wrong hand, so now we're good.